All right, welcome everybody. You can find a link to the agenda in chat. I've got a couple so far. First, just an update on the Reef release. I'm currently planning to consider two things, blockers for the RGW component. One is the versioned object consistency issues that Corey Snyder has been working on. We're going to need those to merge to Reef before we can backport to Quincy and Pacific. So I don't think it makes any sense to wait for the first Reef point release to do that. And second, related to the issue with corrupted encrypted objects in multi-site, Marcus identified compression as another potential cause for that. Before the Reef release, support for encryption and compression on the same object was never supported. But if we release Reef as is, this would be a regression. So either we're going to have to disable that or find a way to fix replication in that case. Shilpa, I know you've been tracking failures related to compression in multi-site tests.
Right, yeah. Yeah, it has nothing to do with multi-part, that's right, but it's compression and encryption.
I think that's right.
Yeah, I don't have an RCA yet, and I still haven't been able to dig into that. But we have a tracker. I'm just going to link it up here.
Yep. I plan to raise this issue with Marcus later today and see if I can get see if we can come up with a plan to fix this, whether we have to disable support or if there's a simpler thing that we can do to fix the replication. But is there anything else that you guys think we should consider a blocker that hasn't merged to main or Reef yet? Okay, good. We can move on then. The next agenda topic is about the async request refactoring. We just recently merged a pretty big PR from CalPesh that extended the optional yield asynchrony to a lot more call paths. And we've essentially have a plan for tackling the rest of them. But I want to figure out a way to get regression testing in Teuthology so that we can, first of all, confirm that we've found all of the blocking Libredos calls and also prevent us from adding new ones. So the optional yield stuff, I think we have a strategy for warning on blocking OSD requests, but there are other places that we could block, like on condition variables or HTTP requests or other things. And so I think we need to come up with a strategy to kind of audit and track those down also. Currently for Libredos requests, we print a warning in the log, something like warning blocking Rados request. And so my proposal would be to turn that into an assertion for Teuthology testing so that we would just crash and fail the test. But obviously we wouldn't want to do that in production, so it would be like a special config variable to enable that.
So what I commented in the PR is that we can try to check that at compilation time. unless you want to make sure that the null yield is not passed. So if we're passing the null yield, then you have to check that at runtime. But if you're if you just want to to make sure that the APIs with the option yield are being called, we can check that at compile time. Why do we need to told you for that?
I mean, we do want to check that the null yield is not being passed. So the issue is we do have to pass null yield for certain things, like things called from RGW admin or from librgw. But we want to ensure that in Rados GWD, we never pass a null yield.
Right. I see it specifically as blocking calls from ASIO threads, like the Beast front end's thread pool. Those are the ones where we don't want to tie up an entire thread. And the logic for printing those warnings uses a thread local variable that those threads set specifically to request the warnings. So blocking is okay in a lot of cases, like Dan mentioned, but it's the specific case of front-end request threads that we want this checking for. And it is specifically the null yield case that they're printing that warning on currently. Does that make sense, Yuval?
Yeah, I still yeah, I guess there's no way to avoid that at runtime. It's just that kind of runtime is a big headache to test. I mean, if you have a couple of them, once one crashes, you have to fix it, and then you have to run the other one and wait for the other one to crash. And also you might miss some stuff that we by chance didn't cover in tautology, or didn't cover, like, I'm not sure we're going to run the entire RGW tautology test suite, which is huge. So I think there could be a way to figure that out at compile time, because I think it's all compile time logic, right? We don't have somewhere in the code where we have an if statement dependent on some dynamic value that passes a null yield or a non-null yield. Different places in the code, different specific code path, they pass the null yield or not. And I think that could be figured out at compile time.
It certainly seems like the kind of thing a static checker could catch.
Mm-hmm.
I don't know how, I guess, programmable static checkers are.
So, I mean,
they're pretty programmable now. I mean, as long as whatever you do is a const expr, then you can write whatever logic that you want.
so the way I see it is that the optional yield type itself is a runtime value. It might be possible for us to like add a constructor to the null yield specifically that checks the thread local variable, or I guess it would be the optional yield constructor, the empty constructor that null yield uses.
Mm-hmm.
But that would be like a runtime check on construction, not a compile time thing. Right. I don't think that we can do anything at compile time that checks whether we're doing something on a specific thread, since it's just the ASIO threads that we want to check here, right?
But I mean, do we even run the ASIO thread in the Redis Gateway admin, for example?
Maybe not currently, but Adam is moving that thread pool out of the front end, making it available for other things.
Oh, yes.
So what I'm trying to say is that if we, regardless of thread, we can't figure out thread at compile time. But if some code, some initializer, some init code, some manager creation, whatever code is running, it can set some global variable that is a const expert and could be checked. So if we are for some reason running those managers or initialize those thread pools in places that we don't plan on using them, or we don't want to be using them, then maybe maybe this is something else. But I mean, maybe there's what I'm trying to say, maybe there's a static way to figure out whether not whether the current code is running inside Boost, but inside Beast thread. But I mean, if we are running in, let's say, in the daemon.
So, I mean, we could potentially add some separate compile option to Rados GW admin specifically that does that checks something differently, but I'm not sure exactly what we would catch there.
Well, just as an example, let's say that the Redis, the RGW daemon has like an initialization sequence and all that stuff that also starts the front ends. Well, at that point, you can set a global variable, like a const expert global variable that it could be checked in this in the empty constructor of the optional yield. And then, if you compile this inside or together with the RGW daemon, then it would assert on that.
So there's one issue that I don't know is maybe fixable or not. We're currently using null yield explicitly in some of the SAL drivers that are not Rados Store. So POSIX driver uses it and DB Store uses it, for example. And those would be built into the Rados GW daemon.
I see.
Right, but I mean, we also have background threads like GC and Lifecycle that are making blocking calls on their own threads, which is fine. We don't want to prevent that.
Okay.
So in a lot of cases, it would probably be easy to get rid of those if we wanted to.
Yeah, I could see all of those background threads being asynchronous and running on the same thread pool. Kind of in the far future when we have time to rewrite everything. But kind of, I think the first step would just be turning the warning messages into assertions in the Toothology environment. That Yuval is right, that doesn't give us full coverage since our tests aren't exercising every call path from request threads. But if we do miss anything and block on one of these front end threads, then that's just kind of a performance issue rather than a crash during runtime.
And we could similarly make an asserting condition variable. Though I'm curious about how, like, do we want to, like, for something like a condition variable, would we want to assert on that if it sleeps at all in an ASIO thread, or only if it sleeps more than a certain period of time?
I would say if it sleeps at all.
All right.
In general, waits on ASIO threads should be asynchronous. And I mean, I'm not immediately aware of any condition variables that we're sleeping on currently, but if we do find them, I would rather convert them into asynchronous waits than replace all our condition variables with a asserting version.
All right.
So the ultimate goal here, next point on the agenda, is about reducing the thread count. Currently, we have a thread pool of 512 threads, which is way too many. The only reason that we haven't reduced it already is that we haven't eliminated all of the blocking calls. And so it's better to have more threads just so that we're not, you know, preventing other requests from running in the meantime. But once we do have good coverage of async requests, I would like to see that lowered dramatically to something like some small factor of the number of cores. But I would love to hear some ideas about how to do performance measurement to figure out how best to size that thread pool.
Well, I think the best option is to try. I don't think there's any. I mean, the theoretical one is the number of cores, but I mean, we have to actually try it out. There was at one point something that I discussed with Matt, probably an idea that came a couple of times, and this is to create a memory store for the RGW, mainly for the sake of performance testing. I guess, yeah.
Could we just instrument the thread pool so that we list the highest point that it gets to, and then just run performance tests with it at 512? And it should not use all 512 if we're fully asynchronous, right? And so if it uses 100, then we can start to say, well, we can lower it at least to 128 or whatever.
Well, these threads are just calling into ASIO's IO context run function. And the IO context kind of just keeps a queue of work to do, and each thread will pick up work as it comes in.
Oh, so it's not an actual thread pool. Okay.
Right. It's like a reactor model. And we expect kind of each time that a coroutine resumes, some thread will pick it up and run the continuation. But yeah, I think starting with maybe twice the number of cores and seeing if we get benefit from going above that. Otherwise, that seems like a good default. Okay. And then the next piece is kind of Adam's wheelhouse, eventually converting from our use of the old librados library to neo-rados, which is essentially async only.
You can block if you want to. It just, you have to specifically say you want to block. Yeah.
Yeah, so I know that Jason Dillerman in the RGW team found some pretty big benefits from switching to neo-rados, and I'm eager to get those same benefits, but it doesn't necessarily need to block the work on reducing thread counts. It can kind of happen over time.
Yeah, I think after we do, what do you call it? After we do the data sync stuff, I can go through, or we can go through and just sort of do it piecewise, do it thread by thread, or do it, the various SAL interfaces, that sort of thing.
Yeah. So, I mean, Calpesh has already been going through and replacing null yields. If it seems like converting to neo-rados could be a pretty mechanical process that I'm sure that he could make progress with, as long as somebody is able to mentor and review on it.
Sorry, just joining. Who's going to do that? Or who's joining that effort?
I suggested Calpesh, who's been kind of working through a similar process with the null yield work.
That's wonderful. If he's here or interested, that'd be superb.
Yeah. Otherwise, Adam thinks that it would be sequenced behind multi-site
Well, it doesn't
metasync and
necessarily.
data sync stuff.
It doesn't necessarily have to be sequenced behind multi-site per se. It requires some of the same stuff multi-site requires. We could merge that stuff in, and then, like, there's no reason once we get many of those pieces merged in, why someone couldn't just run off and start doing that independently while I finish up multi-site.
Yeah. Okay.
I'm happy to donate Calpesh's time if he's interested to help out. If you can coach him.
So I guess one concern there around like gradual conversion from librados to neo-rados is that there would be kind of a intermediate period where we're running both.
Yes.
And sending some requests over one Rados client and others over another. And
well, does there need to be that? What if we instead did something sort of like the POSIX driver or multi-site resharding or something? Give ourselves a timeline to build a thing that tries to be a Flag Day branch.
So yeah. I don't actually necessarily think I don't actually necessarily think the mixed client is actually a problem. So long as like something like SAL object or RGW raw obj is the common currency, like you can't use a neo-rados handle if you in a call with a like if you have an IOCTX, you're going to be using librados. If you have a neo-rados handle, you're going to be using neo-rados. But a lot of functions just get the RGW raw obj and go from there. So as long as you
I see that you probably are right in a way, but we also did going back to the num rados handles alternate universe from the past.
Well, that's true.
That kind of proved that there were serious problems with different paths. I don't know if that's still true, but but seriously, I mean, I was a serious proposal. What if we create a topic branch to do this? Try to get it all the way complete and passing all tests, pulling it up occasionally.
Yeah. We might also just be able to make incremental progress, like subsystem by subsystem, so that any given subsystem is only using one or the other instead of mixing
That's
between
true.
4 different things.
We could kind of follow both of those procedures. I mean, we could hybridize those things and pull over a whole subsystem if it looks like it's solid, and the whole thing passes tests.
Okay, that sounds great. So Dan, you mentioned kind of the issue of cell drivers and support for optional yield. DB stores specifically, we don't really have, at least with SQLite, a way to do asynchronous I/O, and so I think blocking there is just going to be the default always. Other backends could make different choices.
Yeah, I mean, POSIX driver will eventually have asynchronous I/O, at least for some I/O, but it will probably do blocking I/O for other bits of I/O too.
Yeah, like the reads and writes can obviously be async. Some like directory operations, unless there's a way to use IOU ring for everything.
But I mean, things like X adders and stuff will probably always be synchronous.
Sadly, but that's
Okay.
true. IO ring has get dense, so there might be a few places we can catch a lap there, but it's not going to be complete.
Yeah, we could do something like a lot of the Rust async libraries do, where for calls that are always going to be async, we just have we have our thread pool, and then one per core. We have an extra thread, and we just dispatch blocking calls onto that.
Yeah. And I mean, the other option is if we're using a backend that we know is not fully asynchronous, then we just size the thread pool accordingly and be okay with things blocking, kind of how we currently are for Rados.
Yeah,
So in the
makes
long
sense to me.
haul, I would really like to get our backends to be not blocking.
But I mean, things like SQLite are just inherently blocking, right? I think it's certainly while backends are in development, but I mean, I think in general, we will have to be able to support blocking backends.
I was thinking more that for blocking backends, they might have their own thread pool that they manage rather than having all of Rados GW deal with that, so that they would effectively offer a non-blocking interface, but would do their own shunting blocking calls into a thread pool behind the scenes. At least that would be my preference for how to handle it. I mean,
It's
that
okay
would
if
allow us.
it's okay if we have a sort of a good framework for doing that with ASIO or whatever. So
I mean, the main reason is because come the revolution, 50 years from now, if we do get rid of null yield entirely, then we would then that's the kind of interface that we would need to be able to do that.
I mean, pretty much. I mean, that's how POSIX AIO and a bunch of stuff works. Just we want to do it in a way that doesn't make another thread pool mess in RGW. We have some way to decide how to manage and scale it.
There's always going to be a cost to shipping things to another thread, and so I think there will be a lot of cases where it's better just to let things block than pay the extra overhead. All right. Well, that covers all the things that I had on the agenda. Any other thoughts on the async refactoring? How about final agenda topics? All right, let's call it here then. Thanks, everybody.
Thanks. See you.